So dear students, we have finished the line integration, surface integration and volume integration also. So vector integration is complete. Now let me start with the integration theorem. Okay, and the very first one is Green's theorem. We will basically discuss three main integration theorem here. One is the Green's theorem, another is the Gauss divergence theorem, and another Stokes theorem. Okay, so these are just converting of line integration to surface integration or surface integration to volume interconversion between the surface integration, line integration and the volume integration. And here you can say in Green's theorem the line integration can be converted into surface integration, and surface integration is always easier than line integration. So sometimes we can solve surface integration or double integration instead of line integration, okay, by using this theorem. So let me tell you what this theorem actually means, what is the statement of the Green's theorem. Okay, suppose R is a closed region in the xy plane bounded by a simple closed curve C. Okay, suppose we have a region and a simple closed curve is C. Okay, C, this region R is bounded by this closed curve C, Okay, and suppose M and N are continuous function of x and y having continuous derivative in R. So suppose M and N are two function of x and y. So M is also the function of x and y, okay, and N is also the function of x and y. These are continuous function in this region, and not only this, but they are continuous derivative also. That is del m by del x, okay, del m by del y, and del n by del x. These derivatives of m and n with respect to x and y are continuous also. And in this case, if these conditions are followed, then line integration m dx plus n dy can be written as double integration on this region R del n del x minus del m del y into dx dy. And this is the Green's theorem, where C is traversed in positive direction. So here the curve is taken in such a way that it indicates the positive direction, and the positive direction means we have to traverse along C, okay, such that the left side will be always in the region R. So if we travel along this curve along this direction, then you can see that your left hand always will be inside R, okay, inside R, the side of R. So this will be, that is the anti-clockwise direction for this case will be the positive direction, and that is here say that the C is traversed in positive direction. So this is all about the statement of Green's theorem, and as a physics student we need to prove this. Okay, just moreover for this competitive exam like JAM, Jest or NET, get this kinds of exam, never proof is asked. So we have to know only this statement, and we have to apply it in problem. Okay, so now let me solve one problem so that you can understand how Green's theorem can be applied. Okay, so here is the problem we have taken. Okay, so what is the problem? Verify Green's theorem in plane. So we are given a line integration, okay, where C is closed curve of the region bounded by y is equal to x and x square is equal to 4ay. Okay, so here line integration is given, that is xy plus x square dx plus x square dy and the curve y is equal to x and x square is equal to 4ay. So if this is our y-axis and this is our x-axis, then x square is equal to 4ay, curve will be like this, x square is equal to 4ay. Okay, so it will be like this. Let me draw only for the positive side, because here y is equal to x. In this x square is equal to 4ay, curve will be like this actually. The x square is equal to 4ay, but the region between x square is equal to 4ay and y is equal to x is this. So this is actually y is equal to x. So this is y is equal to x, the straight line passing through origin, and this is x square is equal to 4ay. X square, this is the 0, 0 point, and this point will be here y is equal to x. So if we put here y is equal to x, okay, then y square is equal to 4ay. So y is equal to 4a and x is equal to 4a. So this point is 4a, 4a. Okay, now if you want to solve for double integration, then you have to write it in this way also. that it will be just m dx plus n dy. So we have to find out first m and n. You can see m is this function of x and y. So m is just xy plus x square, and n is here x square. So let me first find out the double integration. Okay, n is equal to x square. Okay, so you can see that we have m dx n dx, then we have del n del x and del m del y. Okay, so first we have to find out del n del x, del n del x. Okay, del n del x. So del n del x will be nothing but 2x, and del m del y, del m del y will be x, Okay, so now if you put that we have region on region xy plane, on this region, this is the region actually bounded by these two curves, and we have to take the direction in this way also. So we have to take the direction along this. So this will be the direction of C. Let me take this as C1 and this as C2, and C1 and C2 together will form the complete curve. Okay, will form the complete curve. Now we have to put here as m dx, sorry, not m dx, we have del n del x. Okay, we have del n del x minus del m del y, into dx dy. If you want, you can check del n del x minus del m del y into dx dy, Now let me put. So we have del n del x is nothing but 2x. Okay, and del m del y is x. So 2x minus x into dx into dy. That means x into dx dy. Okay, so we have just integration x into dx into dy. Okay, now let me find out first what will be the limit of the integration x and y. So if you want to cover this region, then you have to take first a small strip. Let me take here a small strip like this. So for this strip, the variation of y will be from this point to this point. So at this point y will be x. So the limit of y, the lower limit will be y is equal to x square by 4a. So y will vary from here to here. So y will vary from x square by 4a to x, and x will vary from here to here, 0 to 4a. So the whole region will be covered. So x will vary from 0 to 4a. So if you vary this portion from here to here, then the whole region will be completed, and here x will be 0 and here x will be 4a. And along this direction, the strip has extended from this point to this point, and this point is what? This point is for the curve x square is equal to 4ay. Along y axis, so it is the value of y, and y x square by 4a, and here the value is y is equal to x. Okay, now you can solve this integration first for y, then for x. Okay, so it will be just integration 0 to 4a, then you can solve for y. So it will be integration x, and integration dy is y, and y will vary from x square by 4a to this. So if you put the limit of y, then it will be x minus x square by 4a. The upper limit is x and lower limit is x square by 4a, and integration dy is y. So if you integrate, integration dy is y, and if you put the upper limit minus lower limit, so it will be x minus x square by 4a. Now the whole expression is converted in terms of x. So now we can integrate with respect to x. Okay, so finally what we get? We have, let me solve here first. So we will get here that integration 0 to 4a, x square dx. Okay, x square dx minus x cube by 4a into dx. So you can solve separately this integration and this with this limit. So if we want to solve, so this will be x cube by 3. So x cube by 3 minus, we have x to the power 4 by 4. So it will be x to the power 4 divided by 4 means 16a. Okay, then we have to put the limit from 0 to 4a. So if you put upper limit, So it will be 4a cube by 3. So it will be 64a cube by 3 minus, if you put here 4 to the power 4 by 6, 4 to the power 4, okay, 4 to the power 4, that means you can write it 64 into 4. You can write it as 64 into 4. 64 into 4, where 4 cube is 64, and 64 to the power 4 to the power 4 means 4 cube into 4 you can write in this way also, and it will be a to the power 4 and a to the power 4, and here is a, so it will one a will be cancelled out, so it will be a cube divided by 16. So 4 and 4 will be cancelled out. Okay, so it will be 60 a cube by 3. So let me put here. So it will be 64 a cube, okay, by 3 minus 64 a cube by 4. Okay, so 12 with the LCM here. So 12 with the LCM, and if you solve this, you will get just 4 into 64. That means 4 into 4 is 16, and 4 into 26, 125, 256 a cube minus 3 into 4, 12 into 6, 18, 192 a cube divided by 12. So now you can do, it will be 2 minus 6, it will be 4, 6, 64 a cube, 64 a cube divided by 12. Okay, so 64 a cube by 12, so your value will be is 64 a cube by 12, and that is nothing but 60 a cube by 3. Okay, so it will be this will be your answer. This will be answer for double integration. Okay, so if you solve this double integration, then you will have 16 a cube by 3. Okay, now we have to solve line integration also, and we have to prove that this is equal to this line integration m dx plus n dy is nothing but actually equal to this del n del x minus del m del y. So what we have done till now, we have done this portion. Now we have to solve this portion also, and we have to prove that the result will be same, that is 16 a cube by 3. Okay, so now let me solve the line integration. Okay, now let me solve the line integration again. So how we can solve? So first we have to solve along this line and then this line. So let me draw the diagram again, so that will be clear for you. Okay, so this is your C1 curve and this is your C2 curve, and the direction is this. Okay, and this point is 4a comma 4a. Okay, and this is x square is equal to 4ay. This is x square is equal to 4ay, and this is y is equal to x. This is y is equal to x. So now let me solve the line integration along C1. Okay, along C1. And what is the line integration? Line integration is m dx plus n dy. Okay, and we have m is given, that we have this m, what we have xy plus x square and x square. So it will be xy plus x square into dx plus x square dy. So this is given. Let me do it for C1 first. Okay, along C1 first. Okay, so along C1, what will be your x square? Your x square is equal to 4ay. So we have to convert it first in terms of x. So we have x square is equal to 4ay. We have x square is equal to 4ay. Yes. So what we have? We have 2x dx. 2x dx is equal to 4a into dy. So what will be your x dx? So dy will be, just 2x by 4a into dx. Okay, that means x by 2a into dx. So that will be your dy. So dy, and y will be, we can write directly from here, that y will be nothing but x square by 4a. x square, y will be x square by 4a. Okay, so let me put here. So if you want, you can put here, you can put here. So it will be just x into, this will be c1, so x into y is nothing but x square by 4a, x square by 4a plus x square, okay, into dx plus x square, and what is dy is x by 2a into dx. So it will be just integration x cube by 4a, x cube by 4a plus x square and plus x cube by 2a plus x cube by 2a into dx, into dx. And let me put the limit of x. X will be vary from 0 to 4a, from 0 to 4a. You can see x will be vary from 0 to 4a. Okay, so your limit will be 0 to 4a. And let me solve it. So it will be just x to the power 4 by 4. That means x to the power 4 divided by 16a, 16, plus it will be x cube by 3, plus it will be x to the power 4 upon 8a, 4 into 2, that is 8a, and limit will be 0 to a, 0 to 4a. Now we have to put 4a here. So first we have to do 4a to the power 4, okay, divided by 16a plus 4a to the power 3 divided by 3 plus 4a to the power 4 divided by 8a. Okay. Now let me solve. Left for you to solve this. Okay, because this is very simple, and you will get here. I can give you the result directly. So you will get here for the curve C1. Okay, so you will get just 208 a cube by 3. So you will get from here 208 a cube by 3. Okay, for C1. Now let me solve the same integration for C2 also. Okay, for C2 also. So how can you solve for C2? Let me solve for C2. For C2. Okay, same integration. That the integration is xy plus x square dx plus x square dy. Yes, okay, plus x square dy. Yes. Now what is the curve? Curve is just now y is equal to x. Y is equal, and the direction is in this direction now. So y is equal to x. So x will vary from 4a to 0 now. The limit will be now 4a to 0. Okay, and we have to put y is equal to x here. So you can take y is equal to x here. So dy will be just dx. Dy will be just dx. So what it will be? It will be just integration x into y is equal to x again. So x into x plus x square. Okay, into dx plus x square into dx. So it will be just x square plus x square, 2x square plus here. So it will be 3x square. So integration 3x square dx. Okay, so it will be just 3x square dx. And now what will be the limit? So limit will be now 4a to 0. It will vary from 4a to 0. Okay, so it will be now 4a to 0. 4a to 0. So what this will be? So this will be 3 into x cube by 3. Okay, x cube by 3, and the limit will be 4a to 0. 4a to 0. Now 3 will be cancelled out, so you will get minus, okay, minus 4a whole cube. That is minus 64a cube. Minus 64a cube. Okay, so this will be for C2. So we have done the integration, line integration for C1 and for C2. Now we have to add these two. Okay, so what will be this? So now if you want, you can do. So it will be just close integration m dx plus n dy is equal to first integration along C1 plus integration along C2. So what will be this result? We have this result for integration C1. For C1 we have 208 a cube by 3. We have just 208 a cube by 3 minus 64 a cube. So if you solve, you will get from here also 16 a cube by 3. 16 a cube by 3. So if you solve line integration, then you can get this result 16 a cube by 3. And if you get this, if you do the surface integration, then you can also get this 16 a cube by 3. So you can say that Green's theorem is verified. Okay, so this result is verified. This result is verified. The line integration m dx plus n dy is equal to del n del x minus del m del y into dx by dx dy. Okay, so this is verified. This is very simple. Okay, you have to do just step by step integration, because all the things that I have done here we have already done in the integration part. Okay, so for these topics we have well prepared before. If you don't see the videos, so please
go to the playlist for vector calculus, okay, and see the videos, and please subscribe my channel so that I can upload more and more video and help you. Okay, thank you.